Question number 9. A toy parachute is dropped from a bridge and falls vertically through the air. You have a bridge, and from here you are dropping a parachute, toy parachute. It's like this. This is what it is. Okay. And as it is falling down, the graph shows the distance traveled by the parachute against time. There is a graph which shows distance traveled versus time over here. Okay. The region of the graph which shows the parachute is at which region of the graph which shows the parachute is at terminal velocity. Now, what do you mean by terminal velocity? I have started time. Okay. So what do you mean by terminal velocity? Terminal velocity is nothing but constant velocity. Constant velocity. So what do you mean by constant? Where do you get a constant velocity in the graph here? See here, what's happening? There's a change in the velocity. In region A, definitely there's no terminal velocity. Region B, there's definitely a terminal velocity. There's a constant velocity here, right? The slope is a constant here. Okay, we just need to look at the slope. So where is the slope constant? Is the slope constant here? There is no slope. The slope is constantly changing here. Now what about this point? Here you see there's no distance traveled, but the time is elapsing, which means what? The velocity here is equal to 0, right? So as a result of it, the right answer is B over here.